Hi everyone, just want a quick shout out to the Wizard of Ozzy Productions for collaborating together with me on this video. This was a little science video just to, spice up little things with more educational stuff, because not only am I only educational, but I'm also gaming and cooking. Alright, so we got just have more variety on my channel, but make sure to go subscribe to the Wizard of Ozzy Productions. The link to his channel is in the description below, so go check him out. He has some amazing stuff coming on his way. Many thanks, have a great day, enjoy the video.
Dear Miss Yang, hi, it's me, Mark45. Some of you who are watching right now might recognize this intro, Game Theorists, because the way they present information is satisfying. Now, DNA fingerprinting, also known as DNA profiling, and it isn't micro-sized fingerprints or a piece of technology, but it is more of a title and a metaphor. Since fingerprints vary within each individual, creative scientists have decided to put them together because it would mean that DNA varies with each individual. It is used in the forensic analysis, medical diagnostics, and DNA testing, and also cloning. DNA profiling was first used in the 1980s. It is commonly used to identify a suspect and to prove innocence for people who are already in prison when this tech wasn't out yet. Having suspects leaving some evidence from their bodies behind a crime scene, and the fact that it is impossible to alter, fake, or forge DNA is critical for this tech to exist. There are other uses for DNA profiling, such as establishing paternity when women do some hanky-panky business, and also in mobile devices. Since there is a 1 in 64 billion chance that any two unrelated people will have a similar DNA, yes, not even identical, it was an easy, foolproof strategy to catch them all. Most people believe that DNA profiling is extremely accurate as shown in the movies, but it isn't all true. Even though it seems like identical twins have the same DNA, we'll prove you wrong even though science says it is. Or do they? In this video, we're going to focus on the two methods that DNA profiling uses and the technology that they both use. There are two methods, but these two are the ones that are used in the most. The two methods are RFLP, which is the restriction fragment length polymorphism, and the SCR test, which stands for short tandem repeat. Restriction enzymes, polymerase chain reaction, and gel electrophoresis are all used in the RFLP method. The SCR test method also uses these three procedures. These will be explained later, but first, let's take a look at the RFLP, which can be explained by separating the whole abbreviation. Restriction fragment is about looking at a restriction gene, and this is possible using restriction enzymes. Polymorphism can also be broken down into poly and morphism. Poly, more than one, morphism, shape, and combined, and it will make different appearances. Restriction enzymes specialize in cutting the DNA that the researchers want, which serves as tiny scissors. They are meant to cut specific sequences of nucleotides. Then the researchers conduct gel electrophoresis, wow, what a mouthful, to find out which areas are different. After using restriction enzymes, this is where PCR comes in. PCR stands for polymerase chain reactions, and it amplifies the DNA, basically copying it. I feel like there should be a penis joke inserted here. It was developed by Gary Mullis in the 1980s because he wanted to make copies of DNA fragments. This is how scientists are able to identify someone from a single strand of hair. PCR is very similar to DNA replication, but PCR happens in vitro, which is Latin for saying artificial in lab. But DNA replication happens inside a cell and naturally instead. Both PCR and DNA replication make copies of DNA, but PCR only copies parts of the DNA after the restriction enzymes have been used. PCR is manufactured specifically to replicate a certain gene. The DNA polymerase needs to be thermostable in order for PCR to happen. Researchers will raise and lower temperatures to start the process. Specific primer is bought and mixed with DNA to form the solution. The solution is heated around 95 degrees Celsius to separate the strands. This is called denaturalization. Then the solution is cooled around 55 degrees Celsius and heated again to around 72 degrees Celsius, which makes the helix reform and the DNA strands appear. This process happens many times to replicate it many times. Gel electrophoresis is a lab procedure which is both used in RFLP and SCR tests, which will be explained later. For this to happen, the DNA must be reduced to a certain gene first. Inserting different solutions from different DNA samples into the well of the device is the first step to perform gel electrophoresis. This device takes the DNA solutions and it sends electricity through it and the gel. The side of the machine has the wells has a negative N and the other has a positive N. Since the phosphates and the nucleotides are slightly negatively charged, the electricity can push the DNA solution through the gel. The protein segments are targeted and heavier segments will be slower, therefore they cannot go very far. Lighter segments will be able to travel further down the gel towards the positive N. The device displays the code on the gel which is colored to make it easier to compare. Differences such as the thickness of the line, location of the lines, presence, absence, and number of lines are noted for different reasons for the RFLP or STR test. Methods such as gel electrophoresis are a recent form of technology, but nothing is really expanding. Mostly, newer and faster methods are being found because the only downside to these methods is time. It could take days just to get some results. In terms of personal identification, the Face ID and fingerprint scanners on mobile devices has recently been popular, and it will be considered as newer developments because this technology has further expanded so the average consumer can have access to it. An STR test stands for short tandem repeat, which is an analysis used to compare specific DNA. It started to get used during the late 1980s, and it is also used to monitor patients after a transplant. The STR test focuses on parts of the DNA that repeats. These sections are called microsatellite, which consists of 2 to 3 nucleotides that are repeated hundreds of times. Humans share 99.9% of DNA, but there are just different genes that make us unique. The STR test also uses restriction enzymes to reduce the DNA into 13 regions where it will be further analyzed. These STR alleles tend to have a lower mutation rate, making it more accurate to the original. It is said that winning the lottery is more likely to happen than finding a perfect match for the 13 regions with 2 humans. These 13 regions are CS, F1, PO, FGA, TH01, TPOX, VWA, D3S135A, D5S818, D7S820, D8S1179, D13S317, D16S539, D18S51, and D21S11. Wow, that's a mouthful. DNA is reduced using restriction enzymes, then PCR comes in along with the performing gel electrophoresis. Using gel electrophoresis, the number of repeats are noted as well as what's being repeated. Judging from the title of this video, you may be wondering why we haven't mentioned identical twins. Understanding this technology is crucial before identical twins are explained. Science says that identical twins come from the same zygote in which after fertilization, they split. They will have the same DNA, right? Yeah, this is true for a certain period of time. DNA also has a tendency for mutation. As statistics say, within the first 2 weeks of fertilization, around 300 mutations have occurred inside the DNA of the zygote. And even though the 2 zygotes are identical when they split, they aren't exactly the same. As time goes on, these mutations are replicated and passed down from the parent cell to the daughter cells. On the outside, identical twins might look similar, but they aren't genetically the same. Phenotype doesn't equal genotype. This is the reason how the mother could be able to differentiate between her own twins. Well, thanks for watching. Sincerely, Mark45 Studios.